Michael Bilkman has an opportunity to buy a perpetuity that pays $24,350 annually. His required rate of return on this investment is 14.25%. At what price would Michael be indifferent to buying or not buying the investment? Alright, so basically we have to figure out the present value of this investment. So let's give it a try. So present value of perpetuity is the first cash flow divided by the discount rate. In this case we have 24,350 divided by 14.25, and that gives us present value of 24,350. 170,877. So a very quick and easy question. The only difficulty is the basic understanding what we're asked to do. So the question, at what price would Michael be indifferent to buying or not buying? This basically means what is the present value of this investment. So if you get a lump sum equal to 178.77, you would be indifferent between taking that sum or buying the investment that pays you $24,350 annually. Alright, let's look at question 9. If you place $50 in a savings account with an interest rate of 7% compounded weekly, what will the investment be worth at the end of 5 years? So this is a simple question of a future value. However, here we have weekly compounding, so we're going to have to transfer our interest rate to a weekly rate. Alright, so let's compute effective weekly interest rate. So we have an APR equal to 7%. That's going to be compounded weekly. To get effective weekly rate from APR, we just divide APR by 52 in this case, because we have 52 weeks. So we have 7% divided by 52, 0.134615%. So this will become our interest rate. So then when we use our calculator, what do we need? We need a present value of $50. We need an interest rate, which would be the one that we computed, 0.134615. That's our interest rate. And we need number of time with 5 times 52, or 260 periods. And let's compute future value. And future value is 70.94. Alright, how did I know 7% was APR, not EAR? If I ever gave you effective rate, I would specify it very clearly. Very frequently rates are provided as APRs with specifically stating the compounding frequency. So this is pretty typical way to state the interest rate and the APR. Alright, so the next question, we actually didn't cover this. This is a tiny little topic that I decided to skip this year. I'm still going to solve it because, I mean, it's easy and it's useful, but don't worry, I won't test you on this topic on your real exam. If the current inflation rate is 5%, then the nominal rate necessary for you to earn 8% real interest rate on your investment is closest to. So this is related to the concept of real interest rate, which we're going to compute by taking the nominal rate and adjusting it for inflation in such a way as here. So let's, I'm going to keep that. So real rate is equal to nominal minus inflation divided by 1 plus inflation. So nominal minus inflation divided by 1 plus inflation. And in this case, what we have is we have the inflation rate currently is 5%. We have the real rate and we have to solve for the nominal rate. So our real rate is 8%. We want to sell for the nominal, and the inflation is 5%. Okay, so we can multiply both sides by 5. And then take everything on one side. So we'll have 0.08 times 1.05. So this one is 0.084 plus 0.05, and that gives us a nominal rate of 13.4%. Alright, 11. Your bank account pays quarterly interest with an EAR of 7%. What amount of interest will you earn each quarter? So here we are going from effective annual to effective quarterly. So effective quarterly rate would be equal to 1 plus EAR to the power of 1/4 minus 1. So in this case, it's going to be 1.07 to the power of 1/4 minus 1, or it's going to be 1.71%. So that's the closest to answer E. Should be 71 here, really. Alright, 12. Harold Hawkins bought a home for $320,000. He made a down payment of $45,000. The balance will be paid off over 30 years at 6.775% rate of interest. How much will Harold's monthly payments be? Round up to the nearest dollar. Alright, so this is an annuity. We have to figure out the payments. Maybe we can do this in Excel. Alright, so what do we have? So he bought a home for $320,000, but he made a down payment. So the present value is actually $320,000 minus the down payment, which was $45,000. So the real present value is $275,000. The number of periods in case of this annuity is equal to 30 times 12, because he has 30 years and monthly payments. So it's 360. The interest rate, we need a monthly interest rate. We are given an annual APR, so we're going to take that annual APR, 6.775%, and divide it by 12. And finally, we're going to solve for our payment, and our payment is going to be equal to PMT, rate, number of periods, present value, no future value, end of period. And that gives us 1788. And that's answer C. Right, let's look at 13. A firm issues 10-year bonds with a coupon rate of 6.5%, paid semi-annually. The credit spread for this firm's 10-year debt is 0.8%. New 10-year treasury notes are being issued at par with a coupon rate of 5%. What should the price of the firm's outstanding 10-year bonds be per $100 of the face value? Right, so we're looking for the bond price for the present value. We're being asked to compute the yield to maturity first, then the price. And remember about semi-annual payments. Okay, so let's see. Alright, so what's the payment? What's the coupon on those bonds? The coupon is coupon rate divided by 2 times 100 of the face value, so it's 3.25. Yield to maturity annual is going to be equal to risk-free rate plus credit spread, right? This is how we establish yield on risk investments. Risk-free rate is based on 10-year treasury note, so that's 5%, and the credit spread is 0.8%. So that gives us yield to maturity of 5.8%. Future value is 100. Number of periods is 10 times 2 or 20. We also have to remember to do an adjustment and adjust our annual yield to maturity to semi-annual to use to our calculation, because the payments are happening every 6 months. So we take 5.8% divided by 2 or 2.9%. And now we put all those numbers into our calculator or Excel. So we have number of periods is 20, future value is 100, payment is 3.25, and interest is 2.9. And we compute present value, and that gives us a price of 105.26. I just want to point out that this question kind of consisted of two parts. There was a question about a credit spread and risk-free rate. There was also a question about present value. In the context of your midterm, those questions would most likely be separate. All right, let's look at question 14. Alan purchases a 10-year $100 coupon bond with 10% annual coupons. If its yield to maturity decreases from 7.45% to 6%, what is the percentage change in the price of the bond? So this one is easy to do in Excel. So let's take a look. So what info do we have? So we have the number of periods is 10. Face value is 100. Coupon or payment is 10%. Oops, sorry. So it's $10. And then we're going to figure out price for two scenarios. So one scenario would be yield to maturity of 7.5%. And the other scenario would be yield to maturity of 6%. Okay, so present value in this first case would be equal to PV. Our rate is 7.5, number of periods is 10, payment is 10, future value is 100. And I'm going to put a little minus before that so we look at it as a positive number, because that's our price. And this is the second present value, so after the change of rate. So this is our rate of 6%, number of periods, payment, future value, and again I'm going to put a little minus here. Okay, so what's the change in price? Of course, we could have expected that since interest rates went down, the price would go up. And the percentage change in price is new price divided by old price minus 1. And in percent, that's around 10%. We want more precise, so here it is, 10.48%. Alright, question 15. Which of the following statements is false? Bonds with higher coupon rates are more sensitive to interest rate changes than otherwise identical bonds with lower coupon rates. So that's actually that's the first question. The first statement is already the false one. So bonds, the smaller the coupon, the more sensitive is the bond to interest rate changes. The extreme example being zero coupon bond, that's the most sensitive to interest rate changes. It's related to the fact that if there's no coupons, or if coupons are very small, then the present value of the bond depends very heavily on the face value repayment, which is very far in the future. And the further in the future the payment is, the more sensitive present value is to the fluctuations of the discount rate. So that's our answer, but let's check out, so that's obviously a false statement, but let's check out the other statements. Bond prices converge to the bond's face value due to the time effect, but simultaneously move up and down due to unpredictable changes in bond yields. So this statement is absolutely true. So the bonds over time will converge to its future value, but they may be selling at a premium or at a discount, depending on the interest rates. Short-term maturity zero coupon bonds are less sensitive to changes in interest rates than longer-term zero coupon bonds. So that's also true. The longer the term, the more sensitive is the bond to changes in interest rates. Same idea as I discussed for point 8. The further away is your payment that you're waiting for, the more sensitive present value to fluctuations in interest rate. And finally, as interest rates and bond yields fall, bond prices rise. That's true. That's always true. When interest rates go down, price go up, and vice versa. All right. Last question in this video is question 16. A firm has an outstanding debt paying annual coupons with a coupon rate of 10% and 8 years to maturity. The firm's bonds are currently trading at a price of $875.50 per $1,000 face value. What is the firm's cost of debt if it has a tax rate of 25%? So this is kind of close to our weighted average cost of capital chapter. So first we have to compute yield to maturity, which would be kind of our bond chapter, and then apply the tax rate, because we know in weighted average cost of capital the cost of that is after the tax. Okay, so we have to compute yield to maturity first. We can do it quickly on a calculator, for example, where we input information about the bond. So we have a future value of 1,000. We have a payment of 100. So I'm going to put the payment as a negative amount. Oops, sorry. What am I doing? Payment is, of course, a positive amount. Let's do it again. This is a bond, not present future value assignment, sorry. So this is our bond. Future value is, of course, 1,000. Payment is, in this case, 100. Positive. Present value is a negative price, 875.5. And the number of years is 8. Okay, and we solve for yield, and yield seems to be 12.55%. And we have to compute after-tax cost of debt, so we're going to take yield times 1 minus the tax rate. So it's 12.55% times 1 minus 0.25, and that gives us an after-tax cost of debt of 9.4%. So this is adjusted for tax.